I'm happy to present our work, Robust Machine Unlearning for Quantized Neural Networks via Adaptive Gradient Reweighting with Similar Labels, which we call Q-Mul. Let me start with the problem. Deep learning is moving to the edge. Phones, drones, microcontrollers. Model quantization is the key technology that makes this possible by shrinking 32-bit weights down to 4, 2, or even 1 bit, saving both memory and energy. But edge devices also collect user data. Under regulations like GDPR, users can request the right to be forgotten. Machine unlearning answers this request by removing the influence of specific data without retraining from scratch. Existing unlearning methods, however, assume full precision models. When we naively apply them to quantized network, it leads to a reduction in the forgetting effect. Our goals are to design a quantization-aware unlearning method and maintain efficiency and effectiveness on quantized models. We identify 2 challenges. Challenge 1, label noise in data processing. Specifically, random label assignment introduces inconsistent noise, and quantized models are less robust to such perturbations. Challenge 2, gradient imbalance in training, causing forgotten versus retained data to contribute unevenly to updates. Here is a quick empirical proof. We ran the classic random labels unlearning on both full precision and 4-bit ResNet 18. The gradient norm ratio between forgotten and retained data is larger in the quantized case. The average performance gap to the gold standard retrain rises from 1.05% to 1.92%. To address these challenges, we propose Q-Mul, a quantization-aware unlearning framework. It has 2 synergistic ingredients, similar labels. Instead of random labels, we assign the semantically closest class predicted by the model itself, drastically reducing noise. Adaptive gradient reweighting. We balance the gradient contributions of forgotten and retained data every epoch so that neither dominates the update. Instead of assigning a random label, we first feed the sample that needs to be forgotten through the current quantized model and obtain its predicted probability distribution. Next, for every incorrect class, we compute the L1 distance between its predicted probability and the probability of the true class. Then select the class whose probability is closest to the true class probability and use it as the new, semantically nearest label. Similar labels works because the new label is close in logit space. The gradient direction remains aligned with the original decision boundary, avoiding the large perturbations that random labels create. Next, AGR dynamically weights the 2 loss terms. This simple yet effective rule equalizes the expected step sizes, preventing the optimizer from over-adjusting to whichever data has larger norms, an effect that is magnified in low-bit models. We evaluate our method across multiple data sets and unlearning scenarios, demonstrating superior performance. Take Safar, 100 random forgetting 10%. Salon is the previous best, gives AG equals 6.05%. Q-Mul pushes AG down to 3.11%, cutting the gap by almost half. The trend holds for 30% and 50% forgetting ratios, and for class-wise forgetting as well. Thank you for your attention. The code and pre-trained models are already open source at the QR code below. I'm happy to take questions. Let's make AI both efficient and privacy compliant.